So here we are, somewhere on what mountain?
This is
Mill Mountain,
Mill Mountain? Oh, okay.
I think.
All right. Somewhere in Mill Mountain area, in an old iron mine, a Riscony formation probably, and this would be limonite. That's the light brown color you see is the limonite, and then the dark black, or the black is manganese, oxidized manganese. And so these two mineral species often occur together in these types of mineralizations. And so this was a place where in the 19th century people worked to bring ore down from the mountain to Van Buren Furnace nearby, along with all the trees that used to be here. These are all no more than about 50 years old, so this was all clear cut as well, as a part of that mining process. Anyway, these are sitting upward like this because these are beds that would have been horizontal at the before Pangaea was formed 250 million years ago, and this was an ancient seafloor, sandstone. There's ripple marks, there's scalithos burrows, things that indicate that kind of environment. And then when Pangaea formed, the coming together of Laurentia, North America, and Gondwana, which is what we call the African continent at the time, and Baltica, which is what we call Europe today, the Alleghanian orogeny occurred, which lifted up the Himalayan-like Appalachian mountains at the time, 30,000 foot mountains, that were eventually eroded down to a plain by the end of the Cretaceous period. And then, of course, during the Cenozoic era, that all changed. You have the Eocene volcanics down near Harrisonburg and other places where the Molehill and others erupted. We think right now that there's some sort of dynamic mantle activity, perhaps related to the subduction on the west coast of the U.S. of the Farallon plate that's been causing the Rocky Mountain uplift. But in the last 15, 20 million years, the Appalachians were rejuvenated and then eroded from there during the ice ages. And at the time, of course, if you think about a wall of ice up in Ohio, Pennsylvania, about a mile high. And down here you have a confluence of dry polar air mixing with warm, moist air off of the Gulf and eastern seaboard. And you get a really, really wet environment. Shenandoah River would have been much bigger at the time, and all of this was much more easily eroded. Of course, this has been mined out, so humans have been involved with erosion here too. But that's why this exists here, and you find these kinds of ridges or hogbacks with a just differential erosion, or weathering rather, all over. Seneca Rocks is another example. That's Tuscarora sandstone. A little younger, that's the equivalent of Massanutten sandstone on the top of Massanutten Mountain. So this is much younger stuff. This is Silurian or Devonian even in age. I have to go back and look it up. But anyway, cool stuff. But a little history there for you.